Okay, Yuta, and welcome to your video tutorial. Today we are going to go through compound interest. It is different from simple interest because it's super cool. Any interest that you earned, instead of being calculated at the end of the life of the investment, it gets calculated along the way so you earn more dollar bills. Okay, unlike simple interest, like I've just said, compound interest is calculated at the end of an investment period. Compound interest is when interest is calculated and added to the investment periodically. It is super beneficial for you and you want it because the investment grows a hell of a lot quicker. So this is the formula. We went through this last year, guys. This seems to be the bit that you really struggle with, but we'll give it a go anyway. A stands for annuity. Okay, an annuity is another name for compounded interest. It's basically like an annuity is an investment that grows over time. It's just one word to describe it. So we use A. A is what we're usually trying to find. And unlike I equals PRN, this is the formula for compounding. It still involves the principal, which is the initial investment amount. But then, because it is a compounding interest, you have to include 100% or all of the initial principal plus the new rate. Multiply that to the number of time periods to get your answer. So A equals P brackets 1 plus R to the power of N. I've color coordinated the relevant parts of the formula below. So the orange of the P is the principal. 1 represents the inclusion of all of the investment, because remember it builds on top of itself. R in green is the rate. We have to convert the rate. It is a percentage. It will be given as a percentage. It must be converted to a decimal. And N is the number of time periods. First question says, determine the amount after 5 years is $4,000 is compounded annually at 8%. So my formula, an annuity equals my principal, brackets 100% of my principal plus my rate to the number of time periods. That's my formula. Now I'm going to try subbing in. Okay, so an annuity equals 4,000, that's my principal. Okay, I might even highlight the question. That's my principal, 4,000. Then I need to take 100%, so 1 plus my rate. My rate is 8%. If I write plus 8, I am doing something wrong. What am I doing wrong? 8%. 8 are two different things. 8% as a decimal is 0.08. Okay, brackets, what's the number of time periods? 5. Okay, if you get your calculators out and you type in 4,000 brackets 1.01 plus, 0.08 to the power of 5, okay, you will get an answer altogether of $5,877.312. First thing, let's round that up. $5,877, and I'll do it to 2 decimal places. The 2 there is less than 5, so it goes 0.31. Now, what is the question asking me? The question isn't asking me how much I've made on my actual investment. It's determine the amount after 5 years. Okay, so if I started with $4,000 and I earn 8% after the first year, any interest I've made is added to my loan. $5,877. Does that seem like a reasonable amount? Yeah. To be honest, that's a little bit more than $4,000. Yeah, for 3 years. Yeah. That doesn't seem too bad. That seems right. So in my account, if I invested $4,000 and it was compounded annually at 8%, I would get about $5,800 at the end of a few years. If you get an answer of $2,000, you know you're going to be wrong. Why are you going to be wrong? Because your initial investment or your principal was more than that. If you get an answer of $50,000, you're also probably going to be wrong because that's an exorbitantly large amount of money. Problem that you guys all have with compounding interest is the rate and the number of time periods. The issue, that last question was fine because we were compounded annually. My rate was annually and I compounded. My compounding time periods was annually. But the issue comes with when the investments are compounded, the issue comes when the investments are compounded in time periods shorter than a year. So compounded monthly, compounded quarterly, compounded half yearly. The rate is usually given per annum, but if the compounding time periods is less than a year, the rate and the time periods, or one or the other, must be amended so they match. Okay, so we have to make changes to our rate and our number of time periods if my compounding periods are less than a year. Let me show you what I mean. Tony's investment of $4,000 is compounded at 8.5% per annum over 5 years. Okay. But the similar question, determine the amount he would have to pay if the interest is paid monthly. Monthly. So the number of time periods is no longer 5 because it's compounded per year, it's compounded per month. Okay, so the time periods is actually 12 lots, 12 months in a year over 5 years. Okay, and the rate is an 8.4% per annum. If I'm compounding per month, I also need to work out what my rate is per month. My principal will never change, but I have to mess around with my other figures. Okay, so the first thing I need to work out is N, my number of time periods. 5 years, compounded monthly means 5 years, 5 lots of 12 months. Okay, 5 lots of 12 months is 60. So let me start my formula over here. An annuity equals P brackets 1 plus my rate to the power of N. An annuity equals 4,000 brackets 1 plus, I don't know what my rate is yet. Okay, close brackets, my number of time periods is 60. Okay, now I've got a little problem. My rate 8.4%, right, is given per year. I need to find out if my number of time periods is in months, my rate must match. So I need to find out what my rate is in months. Sorry, I couldn't say that for some reason. Okay, so I need to find 8.4%, 0.084, and I need to divide that by 12. 0.084 on my calculator divided by 12 gives me 0.007. So 0.7%. Ow. 0.007. So when I get anything that is compounded in a time period shorter than a year, I must amend my rate and my compounding periods. So an annuity equals, if I type in 4,000, okay, 1 plus 0.007 to the power of 60, I get an answer of $6,078.95. If you remember our last answer, it only said 5,800. Okay, and it was for a similar rate and the same principle. This answer, I'll tell you, is right. It is the correct answer. What I want you to do is to write a sentence underneath. Why does Tony's investment make more money? Why does Tony's investment of $6,078 make nearly like a few $100s more than the first investment, which only got $5,877 after the same amount of time? Okay, I'll give you a hint. While that's another 0.4%, okay, that's not the reason. Have a look. Think about the time periods. Okay, and that's it, guys. That's compounding interest.